All right, let's start. Now, next bit.
We're going to be differentiating.
We are looking at its natural logarithm and its graph. So from there, what we're going to do is we will be looking at differentiation and anti-differentiation the next 2 days, and then a bit of a problem solving. All right, using differentiation and anti-differentiation of natural logarithm. But today, let's have a look at natural logarithm first. Now, so you must understand that natural logarithm is defined as the log of base e. All right. You should understand the laws of logarithm is applicable to the log of base e. Solve exponential equation using log of base e. Identify the critical feature of y equals to log x, natural log x, and apply the function transformation in the order of BCAD to y equals to log x. And determine the equation of logarithmic function with sufficient information, plus finally determine the corresponding inverse relationship given a logarithmic or exponential function. Now, so you need to, in this case, recall the Euler's number. Alright, so Euler's number is 2.718, whatever. And remember, it is just a number, and we can use it as a base of a log. And what we do is, if there's a log of 2.718, it's actually log e, the Euler's number, and we normally write this as ln. So you need to make sure that you know the difference, especially for this course. If you've got log nothing, that is log 10. ln is log e, and every other thing else, you need a base. Alright? So this is what the convention we adopt in this course. And if you are at uni, I'm pretty sure log, if you do computer science, is actually log of base 2. So be very careful when you start uni. If you start doing computer science, because when you're talking about binary, I think they use log 2. That's my gut feeling. But just make sure that in here, you know that when you see log is log 10, and ln is log e, and log of base something. Alright? Now, one thing, it doesn't matter whether it's log 10 or natural log, all this still applies. Alright? Yep. I'm not going to go through it, I'm just going to put it up with the lesson slide. You should be able to remember log of a times b is log a plus log b. Log of a over b equals to log a minus log b. Log of a to the power of m equals to m log a. Now, this is a common mistake I've seen. I've seen a lot of people do this. Why is this not right? Why is this not right?
It's the whole thing, it's not just the a.
Yes, the whole thing is to the power of m, not a. So this one is a to the power of m. So be very careful when you look at the power. See where the bracket is. I have seen a lot of mistakes. That is a very typical mistake. Heaps of people do that. And of course, I've done it once or twice before. Not reading the bracket carefully, so I do know that. Alright? So, now, can you therefore evaluate this to two decimal places where needed? If not, you can give it to me. For example, this one, you should be able to give me in fraction.
4 on 3.
So e to the power of 2 is just basically 2. Alright?
One take.
The next few, you should use your calculator. If you're not sure where your calculator is, let's log n square root of 8e. So if you go to your calculator, where's my Alright, so here under keyboard, if you go to main keyboard, so that little bit here, ln, that is what you need to use. Alright? So you can use ln.
I just failed, it's alright.
Right, that is natural log.
But I only need an 88.
That's where your calculator is. So you should be able to work out log of natural log of square root of 8e.
Yeah, it's some
Oh,
number.
now one thing, when you input e, this is what I do. So if you want to do natural log of square root of 8. Now, if you type in e, it actually gives you a space, a little thing there, because it automatically goes to e to the power of something. So if you want e, you can either do e to the power of 1, or you could highlight it and just delete that. That's it. And you get the answer, 1.5397, which is 1.54. So when you do, if you want just e, you can just use that as e to the power of 1, or just highlight that little box and get rid of it. That's fine. Alright?
That's a different question.
Wrong one. Alright, so you should be able to do the rest. Log e, take away that,
1 take 2 of that. That's 4 on 3, and then
and
that's
4 over 3, and so on and so forth.
100.
Alright.
1 minus.
1 minus. Would this be a, what number would that be, do you think? 2 times what?
1 over e.
0.1. It's negative number, so negative is positive. And then 4 over 3 and 9.10. Straightforward?
Yep.
Use your calculator and whatever. Alright, next. Here, you must know your log laws.
Yeah.
You have to be able to combine your log laws. The first one is actually log of x divided by 10. Correct?
Yeah.
Times 2x. And simplify as needed.
2x squared x squared over 5.
So x squared over 5. Log of x squared over 5.
Yeah.
So that is where you need to express as a natural log. Try this one, please. I mean, this one, you can leave it as radical or you can leave it as half. It really doesn't matter. There is no rule because you're not asked to give your answer in radical, or you're not asked to give your answer in positive power. Positive indices. But the way I did it is I just combined everything. I wrote everything in terms of a fraction, not combined. I wrote everything in terms of fraction. It is up to you whether you want to do everything in terms of fraction. I like it that way. So then, combine everything.
Yeah.
That could be it.
That's what
Or if you like, you could do this. It really doesn't matter.
Yeah.
Radical or not, it doesn't matter. No set rule in this case.
B squared.
As long as you recognize what you need to do. Alright? Happy? Can I move on?
2 ln of p is
Good. Next
ln
one.
of p squared.
Now, can you show that x is the same as y in this situation? How would you do this?
You just
Do you what? You just what?
log both sides.
Log both
sides.
Thank you, natural log both sides. So if you natural log both sides, what do you get?
ln of x is equal to ln of y, which means
Yep.
x is equal to y.
So, ln e to the power of ln x is ln x, correct? So therefore,
ln of x is equal to ln of
x
y.
equals y.
X is equal to y.
Now, how could you use this to simplify that? Hence, simplify the following. And then I want an expression in terms of y. I want an expression in terms of y. How would you use your log? How would you use a log to do that? Your log. Yes, log.
X on 4 is equal to y.
Oh, because
No, 4 and x is equal to y.
So, how do you change this? This will be ln x
It's power 4.
to the power of 4.
Yeah.
Right? So, now, if that's ln x to the power of 4, we have 4 ln x, correct?
Yeah.
Yeah?
How do you know that? You don't.
So you can take the 4 out, e to the power of ln x. Use your knowledge of index law. So that is actually just y. Y to the power of 4.
It's basically
Alright?
we used to whatever the power is, which is ln x. Because ln of e in power
So
of one
remember,
is one.
ln x,
ln
e to the power of ln x, you've shown that x equals to y. So that, you can actually take the 2 out, so it becomes 4. for ln x. And then you know that this is, using your index law, e to the power of 4 to the power of ln x,
No, so
or e to the power of
ln
ln x to the
okay,
power
ln
of
of
4.
e to the power of 5. What's that?
So it doesn't really matter. Because you want it
Okay,
in
ln
y,
is
so you
log
therefore, you take the 4 out.
Log base e of e to the power of 5.
Alright, so therefore it's y equals to 4.
5?
Happy? Agree with that?
Yeah.
Alright, next one. Now, you need to be able to express the following in terms of the natural log. Can you remember the change of base? Yeah? So, given that, I think I've written it out. Alright, so you need to recall log A of B if you want to change it to base of C.
Log
Is log C of B over log C of
ln
A.
of 10
Alright?
over ln
So you
of
must, I
2.
think this is in your formula sheet.
Yeah, I think it is. Yeah.
I think it is in the formula sheet. I can't remember.
What's that method spec?
No, the change of base is not in the formula sheet. Alright. This one is not in the formula sheet, you should know. Alright?
Are you up to that in your course?
No.
We just did that today.
Alright, so from there, you should be able to write down that equals to just log 10 over log 2. Now, if you let this be y, how do you solve the following? Sorry, there should be a t there. Let this be y.
It's half.
Alright.
Half integral
Let this be y.
pi of 0. And then
So how are you going to solve it?
the identity. The cos identity.
Now, if you're not using calculator, let this be y.
I think.
Yeah, it would be. Yeah.
If you take log of both sides, straight away you know that x plus 3 is
11.
ln x. If you take log of both sides, is you can rewrite this taking log as into x plus 3 times log 2. Natural log
What's
2.
the half?
And natural log 10.
Yeah, no.
So, that is constant, that's constant. X plus 3 is ln x over ln 2. And you know that if that's y, that will be y. So therefore x equals to y minus 3. Or x plus 3 equals to y. Alright. I should actually write down x equals to y plus 3. My fault.
Y minus 3.
Y minus 3, not y plus 3. It's alright, I'll sort it out when we come back. That should be x equals to y minus 3. Alright? So it's x in terms of y. So make sure that you know how to manipulate your logs. That is important. This is the important bit for this lesson. Natural log is basically the same as the normal log. Alright, example 5. Can you solve the following exactly? No calculator, you need to solve it. What is the first step you would do with A?
Divided by 4.
Thank you. Divide both sides by 4. That's the first thing. You change your... you divide both sides by 4. Therefore, you know that e to the power of 1 minus 2x is log of 5. Alright? And then from there, you take natural log.
Yeah.
Agree?
Yeah.
1 minus 2x equals log natural log 5. So therefore, x equals to 1 minus
x.
log 5 and x equals to 1 minus log 5 over 2. That's it.
Yeah.
Now, like I say, important thing is realizing you can manipulate the coefficient. You can manipulate your e or your log. Alright? Try this please. Try the next one. Now, would I take log straight away? Probably not. I will multiply both sides by 3 first. And therefore I get e to the power of 2x plus 3 equals to 3e. And there, you should be able to work out, if you take a log, what would happen? This is it.
Yeah.
Alright? 2x plus 3 equals log of 3e. Now, what are you going to do with that? Are you going to give me the answer is as 2x, x equals the log of 3e minus 3 divided by 2?
No.
Thank you. Because you could split log of 3e, log of 3e as log 3 plus log e, correct? Remember, you have to do that. Oh, actually, I did not do that. Oh, my fault. I'm half asleep. So it could be log of 3e is, yeah, yikes. That is log of 3 plus log of e. Alright? So therefore, you've got log of e is 1. Right? So it's log of 3 plus 1. Take away 3 divided by 2, which is log of 3 minus 2, take away 2. Alright?
Or ln on 3 on 2, take 1.
So I forgot about that. I realized I made a mistake here. It's not really a mistake.
No.
That
You can
is
always
still
do it
correct
later,
anyway.
yeah.
You should expand it. Alright, next. Happy with it?
Not correct.
I realized that. My own fault. Half asleep when I wrote down the solution. Alright, try the next 2. I'm not going to say anything now. I'm just going to give you some time to do it. D, I will point out a mistake a little bit later that people would do quite commonly, which is what I've done as well, so I know.
Sorry.
Split it. The x is only on the
Yeah.
So
to make this so
yeah, even that's it.
ln x.
Oh, this is a problem.
So you can't do anything about the x, so we have to do is convert the whole thing into logarithms.
Yeah, that's why.
And you can equate it, right?
This is a good question. I like this one.
This is -1.
And then it's just
This is what I do, that's the first thing I do.
no, because you can sort of
Theoretical.
because one and then
2 on x.
Alright?
Well,
I
that's a
take
good
log of
question.
both sides.
Base e, right? So
It was 1, so it's basically 2.
basically the power of -1.
That's a good
So-
question, Sim.
So, next step, I split.
Just whatever that power is there. That's literally what it is.
So I split into here so that I know that this is
Have 1, right? Log e.
a constant. Log of 2 is always a constant.
7e is equal to -7.
Right? And eventually, what I did here is,
and then
this is x minus 1 log e, and this is x times log e, correct? So therefore, log e and log e is 1, so therefore I've got x minus 1 and plus x. So I can cancel off the x there. I can cancel off the x. So log x equals to log of 2 minus 1, which is log of 2 minus log e, which is 2 over e, and x therefore is 2 over e. Do you agree? So this one is slightly trickier
Oh, that's a good one.
in that sense. You've got to be able to use your log laws. What about D? How would you do this?
Oh, it's not that one.
Hey, D is an interesting one.
Is it though?
Aha. How would you do D?
Do the ln.
Going to give you a hint.
Like E of X equals like K.
Different, yeah.
Okay, I'm going to let y equals e to the power of x, and I'm going to shut my mouth. Alright, not saying anything for about 2 minutes. That's the hint. It's a quadratic. It is a quadratic. You have to be able to solve this as a quadratic. And you need to think about when you can solve this. If I let y equals to e to the power of x. So therefore, we know we will have this. Alright? So once you've got your quadratic, you should be able to solve it. And be careful when you're solving this. Remember, there shouldn't be a negative solution, right? In that sense. So you should know your factorizing.
Huh? So 3 times 50 is 150. So we two numbers that add to 5 and times to negative 150.
Oh, no, because
Where did I get this 3?
when you take the ln
My way.
that will be
You know how to solve non-monic quadratics, right? So you got to think about.
Next step. Alright. Now, can the answer be negative 5?
No.
Alright, so you have to state that you need to reject y equals negative 5. Because e to the power of x cannot be negative 5.
Yeah.
You're
Alright?
actually right.
So you need to reject that,
No, it's not true.
Oh, no, it's different.
and
have to
you
use
should be
that one.
able to solve
Just know what you solve.
that. So
This
you
one.
have to write down y equals to 10 over 3 or y equals to minus 5. And then state that you need to reject 5.
This
Minus
is
5, y equals to
because
minus 5.
x
Because e
squared.
to the power of x is greater than 0.
I swear we did it to that.
Alright, you
Right,
must
yeah,
do
yeah.
that.
Yeah.
And therefore,
Yeah, you used to use them.
x is log of 10 over 3.
Yeah.
Do you agree with it?
Yeah.
Yes?
No, you can't, because you can't take the because if you take the natural number and big terms, it will be ln 3 terms plus 5 units. That whole thing will be ln.
Alright, now, let me tell you the common mistake. So,
That's true.
when you take log for both sides, you've got to do it this way, correct?
Yeah.
Yeah? Yeah? So, a lot of people would have done
Yeah,
this.
so how? So when he's actually solving it, so 3y squared
and therefore get yourself into a pickle.
0.
This is not the same
over,
as this.
that's from
Alright?
negative
Just be careful.
We have ey.
So if you got a situation like this, you always let y equals, this is one of the
Negative 10.
quadratic.
So it's like year 10.
Same with the next one.
It's like
Let's
just
solve
solving
this.
non-monoid quadratics. Do you remember it or not? I can teach you again. Because a lot of people don't actually know.
To teach me again after. You just have to times the last number.
Yeah, basically.
By the first number, yeah.
Yeah, and then you do it from there.
And you use the first number.
Alright, try this please.
No, because when you factorize it out, you've got to write this as well. Then remember you do this, you factorize out as much as you can on each one. Plus 5 minus 10y plus 5. And then you bring these two together, bring these two together. And that's it. So this doesn't matter, this doesn't get out to 5, it's just these ones here. Yeah.
Simpler way to write that. I usually let ln x.
I'll keep it for you first. Come on, do that.
Yeah, it is listening to Economic Central in the middle, man.
So let log of x be something. It can be anything. This one is more straightforward than the previous one. This one is pretty much, you can see that this is log of x squared. Alright? So if I let a equals log x, I've got that. So you should know how to factorize. So you can see that a lot of things that I'm teaching you is not new. You just have got to dig deep and know things that you have learned. Alright, if you've done this correctly, you should factorize it as a equals to a minus 4 and a minus 3 equals to 0. Therefore, a equals to 4 or a equals to 3. And
You don't choose.
log x equals to 4 or log x equals to 3. And what you get is x equals to e to the power of 3 or e equals to the power of 4. Alright, do you all agree with my answer? Yep. Thank you. Now, let's think about the graph. Alright? Now, can you show that y equals to log x is the inverse function of y equals to e to the power of x?
Show. Oh, you just gotta do the opposite way around.
Yeah? Now, when you want to do the inverse function, what do? You need to swap y and x. Alright? Remember, doing the inverse function, you swap y and x. And therefore, let's do x equals log y, and then we'll arrange it that way. So remember the mapping, y is mapped to x is mapped to y. Alright? So, and therefore, you know y equals to e to the power of x as inverse function. Now, if you sketch it, if you draw it, you would have y equals to ex. Alright? And you can see that the intercept here is 0, 1, whereas the intercept here is 1, 0. Alright? Here, the asymptote is y equals to 0, y equals log x, the asymptote is x equals to 0. Alright, and the reflection is, the axis of reflection is y equals to x. That is the inverse function. Right? Now, let's have a quick look. That is what I've stated up there. Now, the next thing you need to know, the graph of y equals to log x, natural log of x. The vertical asymptote is x equals to 0. X-intercept is 1, 0. Describe it as x approach infinity, y approaches infinity as well. As x approaches the 0, y approaches negative infinity. Yeah? Happy with that? Let's go. Alright. Now, let's move on. So transformation of y equals log x. I've been through that a couple of lessons ago when we looked at the log 10x.
I would have done it your way as well.
So actually it's basically the same. You use b cat.
Yeah.
B and C affect x. A and D affect y. Alright? So you should know that. Remember the transformation b cat. Now,
you use a tree.
second example.
Like x is on the top.
Yeah.
Consider the function fx equals to 2 ln x minus 1 plus 1. How do you describe the transformation? How do you, if I transform from log x into that, how do I describe the transformation? So remember your b cat, you are going to describe transformation of x first and then transformation of y.
So we're going to do a
Alright.
translation.
So b is 1. So minus 1, do you move it to the left or to the right?
Left. Wait, right.
Right. All right. To the in the positive y direction,
Yeah.
x direction. Sorry. 2 is dilate.
Dilation.
What factor?
2.
2. And this one is
Move
Vertical
one up.
translation.
vertical translation. All right. So what you need to do is describe.
Sure.
ECAD.
Translate in the direction of the positive x-axis by 1
So the
unit.
same thing as pizza.
Now remember, when you describe, always state the number of units is translated.
Yep.
Always say that. And again, dilate by a factor of 2. Give the factor as well. And then translate, again, give the number of units is translated by. Alright, make sure that you always say that. Now, therefore, can you state the vertical asymptote?
Yeah.
What is the vertical asymptote? X equals to 1, thank you. And then you should be able to state the domain. Right? So the domain of fx. Oh, I didn't write down the domain of fx. I'll do it. The domain of fx should be
What do you mean?
x is such that x is a
Because they're both one.
member of R and x is greater than
B
1.
is dilation as well.
Alright?
like
So that is a domain.
yeah,
Yeah?
that's what I said.
Okay? So fx is, so determine the coordinate of x-intercept. Fx equals to 0.
B is this.
So you can work out
A is this.
x equals to
C is
1.61.
this. And D is this.
That's a calculator. You should use your calculator for that.
No, D is this.
Alright?
A is this.
Now,
B is this.
here,
Then
you are asked to locate at least one extra point when you draw it. How do you locate? What other point can you locate?
When x equals 2,
Why?
because then ln will be 0.
Very good. So when x equals to 2, ln equals to 0. So therefore that's 1. I'll show you.
yeah.
So in this sort of situation, recognize that what you want is, because when you the first bit of information you have, you can work out the x-intercept. So you got 1 point. You know x is that, right? So the next bit of information you really want to think about is, let's have log of x minus 1 equals to 0. Alright? So, I've already got that point, your x-intercept. Now, another point, you need to think about log of x minus 1 equals to 0. Makes life a little bit easier, because then you can actually find that exact point. So you know x minus 1 will be equals to 1, because log of 1 equals to 0, so therefore x equals to 2. Once you know x equals to 2, you can substitute into the same, back into that equation. you know that that's already 0, so f2 equals to just 1. And you've got 2 points, 2, 1. Draw your asymptote, and that's it. Sketch it. Alright? So
Yeah.
those 2 points will give you a sketch. And then always write down your equation. Alright, one last example. The last example is to identify the, determine the equation. Now, you've got 3 points given to you, A, B, and C. And you also know that the exact coordinate for A, B, and C. And you need to find P, Q, and R in this equation. Alright? So the first thing you need to do, very obviously, is look at what Q is. What is the vertical asymptote?
2 minus 2.
Is that vertical asymptote is x equals to minus 2, correct?
Yeah. So Q is positive.
If vertical asymptote is x equals to minus 2, Q is therefore 2. Yeah?
Yep.
Because if it is positive, it's moved in the negative direction. Alright? So Q is therefore equals to 2. You've got 1 down.
P has to be
Now
negative.
then you use all this information. What other information could you use to find R and P?
P has to be negative.
Okay? It's up to you, but I'll use y when y equals to 0. So when y equals to 0, which is that point, we know what x is. Alright? So x, substitute in there. You know this 2, minus 2 plus 2 is 0. And you know that that's log of 1 over e, which is minus 1p. But I'm just going to leave it here. You could write it out if it is not calculator, assume section. Alright, if not, I'll leave it there because I fed it into my class bag. And then the next bit, when x equals to 0, this is point, and we have that. So you've got that equation there. Alright? So therefore, what I've done is, I just use class bag and I solve it. So P is minus 1 and R is minus 1. You know that P cannot be positive because this is already a reflection. It cannot be positive, it has to be a negative. So that's reflection.
Yep.
And use your class bag, you can work out P and R. And therefore, that's the equation. Fx equals to minus ln x plus 2 minus 1. Alright? Now, you need to determine the inverse function of fx. So since you know this, you need to swap your x and y. Alright? Swap your x and y. So I'm going to do it in a different page.
What was P, negative 1?
So that is the equation that you have.
Negative 1?
You know y equals to minus ln x plus 2 minus 1. Let's swap x and y. So x is therefore minus ln y plus 2 minus 1. Once we swap it, you could work out x plus 1 equals to that. Minus ln x plus 1 equals minus ln y plus 2. Now, what I would do is, I will not change this to negative. I will actually bring that in as a minus 1 to the power of minus 1 so that I've got it as a 1 over y plus 2.
There you go.
Alright, I've got it as a 1 over y
To
plus
the
2.
negative x to 1.
So therefore, e to the power of x plus 1 is y over 1 over y plus 2.
Yep.
Yeah?
Yep.
Happy?
Yep.
So therefore, you know that's the case. Y plus 2 equals 1 over e plus 1, e to the power of x plus 1, and therefore this is your inverse. Y equals to 1 over
Why would you do it
e
that way?
to the
sir?
power of x plus 1 minus 2.
Just make
Now,
it negative x and negative.
Domain.
Yep.
Y has to be greater than 2,
Yep.
Because that cannot be
0.
0. And x can be any number.
Nice.
That's all. Alright? So important thing is recognize you need to use you need to use a point and know your transformation.
Yep.
Alright, that's all I have for you today, and there's some exercises in Google Classroom for all of you already.
So, can I go to the bathroom?